Good afternoon, everyone. Welcome to today's edition of Graph Guy. Once again, I'm Clark Ritchie, and I am the Graph Guy. Today, we're going to be having our second guest aboard, who's going to be talking to us about some of the how do we consume graph information, particularly from a sort of a front-end application perspective. In the past, we've been talking a lot about the nitty-gritty about how to model our data and how to get things set up and problems we can solve and so forth. And now we want to talk a little bit about the actual consumption of that data, as well as how it can be dealt with and manipulated on the programmatic side from a web perspective as well. So there'll be definitely some kind of technical content in there for sure as well. So with that being said, we're going to switch over and welcome Adam Wabnitz to the show. Hey Adam, how's it going? I am hanging in. I am really good. I'm trying to still working on the whole Zoom, on the whole Twitch studio thing, trying to make sure I've got everything unmuted and working on multiple screens. I'm doing a terrible job at it mostly. But great, yeah. So Adam is a very senior web developer, web architect. I've been working with Graph for a while. Adam, why don't you tell us a little bit about your background and about yourself?
Yeah, for sure. So I've been a lead web technologist for a company called Beez that deals with graph databases for about the last 10 years. Concentrated on visualizations of network graphs and also the querying and API consumption as well of that data. So yeah, been focusing on graph for about 10 years now.
That's awesome, and now people can actually hear that and not just have to read your
Yeah,
notes.
that's
So
great.
that's important. Um, man, so you can tell I don't do this professionally, not the Twitch streaming portion. So let's dive into that a little bit. And as I was saying, we often talk about Neo4j on this stream. We're big fans of their product. And Neo, right? Neo has some visualization capabilities, right? It's been effective. Let me go ahead and bring that up as well, and I'll share it. So, so here I'm in a web browser, and those of you who've been on the show before, watched the show before, you've seen this. That this here's Neo4j's web browser, right? And so I can go into here, right, and I can do. Oh, Zoom's going to crash on me. Maybe. Yep, Zoom crashed. Okay, so we're going to get Adam back here probably in a second. So we talk a lot about Neo4j in the show. We're big fans of theirs. We don't talk about Zoom as much. There may be a reason. Anyone who's watching who's from Zoom, feel free to yell at me. That's fine. Yeah, when Zoom crashes as well, it tends to lock up the CPU in my computer entirely, which is impressive because I am running with a lot of CPU. So let's see if we can recover this. I'm trying really hard, but there's tragically little that I can do. If you're still there, you can see my mouse. There it goes out. Good. So we can see that my mouse is... there we go. Alrighty, so I think we've got Adam back, which is good. Yep. Yeah, there's Adam. All right, man. Let's get back to sharing. I can apologize for that. There's nothing I could have done about it, but here we are in our Neo4j browser. So then, I can jump in here, right? And I can, as you showed them before, I can say, match n, return n, and I can see stuff. Let's get this out of the way here. Right in it, I can make it larger. I made the wrong thing larger because I'm not good at things. But here we go. So here's our. There get them out of our way. So like here's a network graph, and I can zoom around and things. And this is great. Like I use this a lot when I'm developing and writing queries, and I suspect you do as well. And I mean,
Oh yeah.
you know, we can color code things, right, and change stuff. And I think this is. I know you'll talk about this more later, Adam, but I think this is a. Would this be considered a force-directed graph? Is that what this is?
Yep. So it's a structured force directive graph.
All right. So I've got a bunch of things in here. One thing we can see. I mean, I got a lot of stuff, and this is not meant for massive amounts of data, right? It's meant for I'm writing queries and exploring my database, and it's good, right? It's really good for that. It's certainly much better than the days when you have to use relational databases and you were stuck in some kind of a terminal and you were looking at data coming out as ASCII art if you were lucky. So there is that, but there's a lot of other ways to deal with that, right? I mean, so I am having so many Zoom issues right now. Normally, I'm actually a big Teams guy. But I have not been able to get Teams to work well with my, there we go, with the audio on Twitch. All right. So, Adam, why don't you kind of walk us through some of the main techniques that you like to use for visualizing data that comes from the graph?
Yeah, for sure. Okay, so first, I guess when we talk about network graphs, I think, at least in my personal experience, a lot of people overuse them right now. So I think the first question you have to ask yourself when you're trying to represent graph data in a chart-like structure is this necessary? So like you said, one of the main issues people have is they want to take all their data and they want to dump it into a network graph.
Right.
Which is great, but what you get is called a hairball, right? And that cluster of data is very hard to read and visually represent in a useful manner. So I think that's something people need to be cognizant first off of when using network graphs is first ask why, and then before you ask the how. All because you can.
Yeah, no, that makes a lot of sense, and that's an excellent point. So I used to work a lot in the U.S. government defense and intelligence space, and a lot of the work that was done there was graph or graph-like, right? And a lot of the analysts would use different tools to look at things in their graph, right? But those people were they were trained analysts, often trying to find patterns and connections and things, right? And so they could spot things visually. But most people aren't trained analysts like that, right? We just want to go to a site and get the information we're looking for, right? So is that kind of what you're talking about?
Yep. So exactly. Now, if you're an analyst or a data scientist and your main thing is you're looking at patterns, right? What network graphs are really good is at pattern recognition, clustering, things like that. But for simple things like, person lives in this city, this city's in this state, there's usually better ways to display that. Now, you can still get that from a graph database, and there's still benefit to doing so. But for just a solely visual representation, network graph or something like that's not going to be best. But exactly what you said, if it's something that's more pattern-based or degree of separation, network graphs really stand out.
Yeah, now, I think that makes it correct. Because a lot of times we talked about that in prior shows when we're describing information to people. Lots of times it's pretty natural for us to kind of like draw circles and lines to describe those patterns. Right? But I think when we're receiving information, right, like when I ask you a question, I look up data and get information back. We're much more used to looking at things in tables or lists that's like super easy to digest. Like I don't have to think if I read down a bulleted list, right? So like in our Word documents, for example, or there's like 4 or 5 ways to create bulleted lists, and everyone understands those since we were young. There are no ways to insert easily, like network graphs in them, because I think those can be for most people harder to consume.
Oh yeah, that's just to your eyes and to your brain, the way you visually represent the network graph. You're solely concentrating more on how they relate and seeing global patterns, like overall structures instead of actual individual details. Where things
Right.
like a table, line charts, stuff like that's going to be better for that.
Right. So
But
let's explore that for a second. So let's say
mhm,
though I am in one of those groups. I'm a data scientist. I'm an analyst, and I am looking for these visual patterns and things. Um, what are some good ways for me to go about that? What are some techniques out there that
yeah.
we should be aware of?
So the main one that people use when they use network graph is called force directed layout. Now, there's static and there's organic force directed layouts. Now, I guess before we go into that, I can kind of explain how those work. So those are based off three main points. You have repulsion, springs, and network energy.
Ah,
Um, so in the model, nodes are the balls, the entities. They're treated like charged particles that produce a repulsive force that sets them apart, right? And that force is inversely proportional to the square of the distance between them. So if they're close together, that force moves them stronger apart. If they are weaker, or if they're farther apart, that force is going to be weaker, right? So you're going to have that movement. Then you have the spring, which is that's what same thing, but that's what pulls the nodes closer and produces those clustering. Because each spring, which is the relationship, has a natural length, which is controlled by something called the tightness layout option. If it's stretched farther out, it'll pull it faster, closer to snap, and so forth. And then finally, the last part is that energy. And that's what sets each node to move in a random direction. That's what kind of makes it that compulsion.
wow, we've
Um,
gotten deep into math and like particle physics. So
I
this is
know,
cool.
I know.
Can you show us something of this so we can better kind of get a handle on what
Yeah,
you're talking about?
yeah. I'm a little afraid to share with Zoom right now, just because I don't
Ah,
want it to kick me.
I
But
typically only crash once per meeting, so I feel
okay,
like I'm going to be okay.
it's disabled for me right now. Part, host disabled
Well,
participant
I'm
screen
not.
sharing.
Maybe Zoom crashes for me because I'm not good at Zoom. So let me off the share screen. There you go.
Okay, let me.
And now we should
Yep.
be good.
Let me make
You
sure
guys
I'm
probably
sharing
did
the
not
right
realize we were going
screen.
to get into math and particle physics today, but we did.
Oh yeah. Okay, so can you let me know if you can see my
Yeah,
screen?
absolutely.
Okay. So as you can see, there's that motion, that movement of repulsion. Um, the elasticity is not so much in there, so you don't get so much of that pull, but there's also that energy as well. Now, what's good about this is when you're dealing with huge, complex networks of data. I'm sorry, let me close that out. Um, when you're dealing with like huge networks, and you need a network that can, or a layout that can reveal underlying structure of every connected component, this works great. Force directive layout minimizes overlap in the graph and evenly distributes those nodes and links because that spring length is consistent. Um, but there's also a bunch of negatives, I think, when it comes to force directive, especially static. So here, like, we'll play it again just to show you. I get to, there we go. That animation that's happening a lot of time is just too much. It makes it hard to read that graph, right? So again, this is when you have a force directive layout. That propelling is part of it, and a lot of times that's overkill and not necessary. Um, to me, especially if you're looking at something like time series data and you want to see things add and be approached in a time data, when things add in that movement, you can't identify those different patterns and recognize that. So personally, most of the times I do not like force directive layouts. That's a personal opinion, but I think there's better ways to read this data unless you're solely just looking at patterns and clusters. So does
So
that make sense?
yeah, I think do you have an example we can play with the force directed graph here too? Because I know one of the things that I know I don't know why, and maybe you do, Adam, but people tend to like force
Bounce them.
directed seems to be the default for a
Hmm.
lot of people, right? They certainly do for a lot of representations, um, and I mean I guess because it does kind of look cool and things move around a lot and people like animation and things, right? But for
Oh yeah.
me, right, a lot of the problems like I have is yeah, exactly that, right? So like I
Yep.
see things, I'm like, oh, I wanna move some things around because I want to explore something, and that's exactly what happens. They bounce back, and it
Oh yeah.
really inhibits my ability to then shape things in the way I want to see them. So that's personally that's my hang up with force directed as it were.
Yep. Yep. I agree. And a lot of the times, especially when you have something as airy is the movement here. Um, you're going to get users not using your tool in the way you want. They're literally going to be sitting, like you said, doing this. And you see all these other motions moving here. It's really hard to, you know, see those patterns and identify them unless this was truly static. Because right, those spring lengths have to stay consistent.
And this isn't a big graph here, right? But I would imagine that would
No.
be pretty CPU intensive or GPU intensive, depending upon the underlying thing as well, all that movement, right? So that could be an issue. Okay, so what are some other alternatives?
Okay, completely static version of force directive. So that's really good if you want to see items being added, changed, or removed from a chart that are still a lot of data, right? And still pattern and cluster driven. Because it uses less energy than the full layout. So nodes move as much as they need to and no more, right? So if I add a node here, you know, and say it had to go here, this one would move, but the rest of these would stay. So it's really easy to recognize change in pattern. But some of my more favorite ones. So this right here is, again, another force directive, but it's using node size to differentiate importance of nodes. So for here are these people nodes, and are larger based off the amount of connections they have. Again, good for large data, but again, there's better options, especially when you're dealing with, over here on the right, you see singleton nodes. Most network graphs won't lay them out this pretty. They will just randomly throw them in the middle of here, and you have really hard time to find these entities that aren't related to anything.
Right, so that node size is interesting, right? That almost sounds to me like a visual representation of Google's original PageRank algorithm, right? It's like, you know, PageRank's gotten significantly more complex, and it's not what Google uses any longer. But right, that was originally about you know, giving a page more relevance in search by the more things that linked into it. So that feels like what this is seeing, and I could definitely. You know, see where that could have some use. Right, there's a lot of nodes on here, and if I had to count like lines, that would be a nightmare, right? But if I can now visually see, oh, that like Mark Taylor has a lot more, you know, connections than Mary Cook. That makes that a lot easier for me.
Yep. Yeah. Again, this is for very quick, you know, analysis of what you basically just said. Is like Mark has more connections than this person or John. Quick things that you're not going to be counting individual relationships or, you know, doing anything more specific than that, but for general glance of what has more edges or connections, this is a great form of graph as well. Again, this is another one that's like that. We won't show that one. So this is a what's called a lens layout, and it's designed to push highly connected nodes into the center.
Can you click on your full screen button in that little animation there? So we can
Yep.
There we go. That's
there
awesome. Thanks.
Sorry.
That's good. It's make it easier for our viewers to see.
Yep. So this is called a lens layout. It's designed to push highly connected nodes into the center, right? And nodes in the periphery are those connected nodes. So this is, again, really good for smaller graphs. You're not going to want a huge clustered force structured graph on this one, but to actually see certain types of entities and how many by degrees of one separation usually is best for this lens connections they do have. So if you look at the blue ones, these would be your main entity types here. Same with these orange ones here, and kind of just see what those first degree of separation are. A lens is really good for that.
Nice. That seems pretty straightforward. The animation is neat.
Yeah. So let's go to the next one. Okay, so let me large this. Well, this is an image, so I can't large this one. So this is called a structural layout, though. Actually, here, I can use my development skills.
Look at you. So not only have we done math, we talked about particle physics to some degree.
There we go.
And now we're into like hacking your own web, hacking the web page like that. It's like the old web monkey stuff.
Oh yeah. So yeah, this is a structural layout, and it's similar to a standard, except it groups nodes with similar attributes together in fans. So particularly useful to get an overview of network clusters or identify groupings that may not be obvious. So here we see, you know, over here and over here, there's these different groupings of where nodes are pushing. We're going to know that these have similarity. Now, a lot of times you'll put filters based off of different identities or properties or relationship structures off these nodes to say, hey, show me, let's group by gender. And you can see your main nodes, and then, association, it filters out based off those properties for gender, or so forth. So that's really good for that fanning of getting an overview of clusters and the groupings that might not be obvious in a force directive.
Yeah, no, I like that. That seems pretty easy to understand.
Oh, yeah.
I'm going to guess this is another structural type based on the picture?
Yep. So this is sequential. So let me enlarge that one for you. So this is a good way to display where there's a clear parent-child relationship between nodes, but where the nodes also have a set of tiers at levels that need to be communicated. Right.
So it's a tree structure, basically. Like
it's a tree structure.
Yeah.
Yep. So it's perfect. Yeah. When you have, a tier or child-parent relationships. Again, way better, easier to read, to see those relationships than a force directive when it comes to, walking the tree. And then the last one that is, one of the more basic ones is called radial layout. So here you can see arranges nodes in the concentric circles around the original subjects in a radial tree. Each generation of node becomes a new orbit. So you have this orbit and you have this larger orbit, extending outwards, showing a dependency chain. Usually this layout is the best option for networks with large volume of child nodes to each parent. And also when you do care about that generation steps and the degree of separation from your original nodes. So it's another very useful graph as well.
Nice. So you've talked and showed us a number of different layouts.
Mm-hmm.
And we talked a little bit about the uses for each. So if I'm out there and I'm a developer and I'm trying to pick a package that I want to use for my layout, it sounds like one of the main things I want to look at would be what type of layouts are provided by that visualization package. Is that a fair assessment?
Yep. I'd say the layouts provided, as well as the ability to customize through the library. So, for example, you might not care enough about having like glyphs, right? Like notifications on individual nodes and stuff like that. Then you don't need to go with something as intense as like a key lines or a D3. You go something a little more simple. But yeah, your main thing would be, I think, deciding what kind of data you're going to be returning and what layouts best represent that data.
That makes sense. And for those of you who haven't tried to export it on your own, layouts is in this case is hard. There's a lot of math that goes into figuring out where to put things based upon the patterns and Adam talked about and so on, and looking for collisions and so forth. So yeah, having to not do that on your own and to have an implementation that is fast at doing things, is really worth the money more often than not. So we're getting near the end, but let's pivot a little bit and get away from the pure visualization, and let's talk about like the data transport and access a little bit, right? So we've talked a lot on this show about how you directly communicate with the database. We've talked about Cypher. We've mentioned some of the other languages that are out there. But we've focused on Cypher. And in our last show, we actually showed how to use Neo4j's Java API through the Bolt driver to access data from the server side as well. What are your thoughts on accessing this information from the front end? Because in a lot of ways, that's just as important. If we can't get that information to the user in a meaningful way, then the whole process doesn't amount to anything.
Oh yeah. So as mainly a web developer, two most important things I have to deal with. One is displaying information, and the other one's retrieving information, right? So we deal a lot with APIs, which is Application Programming Interface. And the two main that I see that, on a project level is REST versus GraphQL. So we're not on the front end, we're usually not writing queries per se, as in Cipher or Gremlin or SQL even. That's handled in that middle tier, that backend architecture. But we do have a lot of decision, especially nowadays, between how we want to ingest API, and especially when you're dealing, everything's so data driven nowadays, especially in a graph database world, that data is dictating how applications work and how applications not just render, but also ingestion and update data. So I guess not to get too in depth about the differences, but for those that don't know, REST used to be the standard that was identified in 2000 for data retrieval. It's based on accessing data by URLs. It stands for representational state transfer. And basically what that means is, what I would do as a front-end developer, let's say I want to request a user and get his 5 last reviews, right? So we'd have in our graph database, we'd have a user. They would have edges that associate to reviews. Usually in a REST structure, I would call for that user based off ID to get a list of those reviews. And then if I wanted the top 5, I would send 5 additional requests to get 5 reviews. Now, there's a new form that came out in 2012, it became mainstream in 2015, made by Facebook, called GraphQL, which, although it says graph in the name, it is not solely graph database. But in structure, the way the graph's received, it kind of is. So basically what it does is it takes overarching data structures, basically in JSON objects, which I know too technical probably, and deliver it to that user. But one of the good things about doing that is what we took in a RESTful architecture, an API that would be 6 requests, I can request in 1 request. Now, that's because the client side actually gets to handle that query, and I get to nest those results inside of an object, a JSON object, to communicate to the front end. Now, not to get into too much because I know you're short on time, there's a lot of pros and cons about both, which if you want to discuss ever, we can do that. But yeah, main way right now I would say are those two that you would communicate with large data sets. RESTful if you want more structured in your response, and more larger queries that are a little more advanced. If you want to simply just manipulate or ingest data, GraphQL would be the faster option.
Yeah, that makes sense. And I know GraphQL is getting a huge amount of traction. You said Facebook created it. I know Amazon has been pushing it a lot for accessing their services. Others have as well. There's a number of big companies out there doing interesting things with GraphQL. And as primarily a server-side engineer, I understand that the data that I return to you either from REST or from GraphQL, I have a tremendous amount of control as to what that may look like. But regardless of that, would you say that if we're thinking about our data as linked objects, right, nodes that are linked by relationships to other data nodes, whether or not we display that, visually in those, or we make them into lists and tables, whatever it might be, do you find that one format or the other tends to more naturally lend itself to an easier representation of that? Meaning, like, does the inherent structure in GraphQL tend to fit that a little better, or is it not so much a factor?
I think it depends on how large your data is. So yes, GraphQL, the structure will better represent, I think, from a linked, an edge to node data structure. It's definitely going to represent that better. Just from a soul, what you're returning. But at the same time, it's because you're returning so much, it's the same like issue with the network graph, right? Like now I can dictate what I return, only portions of that request or whatnot. But you're putting a lot of control in client side, and you're saying, you might, a lot of times they'll return that whole cluster, that whole force directive graph, and you're getting all this data. And now I'm spending all this time manipulating that to actually get to a visual representation, where you're having more structured data on a REST call, right? And I can say, like, I specifically want this, and this is how it's going to come. Now, I'm not going to know the schema for every call as easily as I am for GraphQL, because GraphQL is more type-based, structured, and it's going to tell me this is how everything's going to return no matter what my request is. But yeah, so I mean, honestly, I evaluate it per an application, per what the actual need is.
Right, and that makes sense. I think that's good advice, yeah, for any of these types of choices, right?
It does, on the surface, it does represent like a property link graph or not RDF so much, but LPG structure more based off of its returns in GraphQL than it does in what most people would return in the RESTful.
Yeah, and I think it is important to call out for people. A lot of people here. I hear two things a lot in this general space. I hear one, you talk to people about a graph database, and what they really they say, "Oh, I love graphical databases." And I'm like,
right.
No, right? We're not storing pictures,
Right.
but I think they think about it like those pictures you saw earlier in the videos, right? So that's what they think about. And I think the second is, I think a lot of people think GraphQL is inherently a way to query a database, which is not true, right? Like I said, it's a services API structure and way of asking and structuring data. Now, there are some projects, tools, etc. out there that do let you query a data source directly, but that's not the inherent original purpose of it. And for the most part, that's not what's happened. It tends to be something else in the middle. It may come from a database. That database might not even be a graph database, right? I might be serving up GraphQL from a relational source or something like that.
Yep, it's more so the structure. And yeah, what you just said about the pooling, a lot of people use what's called Apollo, which is a company that lets you kind of simplify that and query that. And a lot of people are using that with GraphQL right now. It's kind of
they're probably one of the largest GraphQL players out there right now in terms of services and so forth. Absolutely. Well, excellent. Well, Adam, I really appreciate you coming in and giving us that perspective with all of your experience, and maybe we'll get a chance to have you on again sometime.
Yep. Thanks for having me. Excellent.
Thank you very much.
Yep. Take care.
And take care, Adam. All right, and so that brings us to the close of Graph Guide today. I hope this was interesting. As always, if you have questions, thoughts, comments, topics you'd like us to cover, hit us up on social media, go to the website, hit us up again with any of those ideas, and we'll try to address them here. That contact information will be on at the close of the stream. And I will see everyone hopefully next week. Thanks for watching. I'm Clark Ritchie, and I'm the Graph Guy.